Good morning, everyone. Today we are discussing the problem which we had discussed in previous video, that when we are converting a binary tree into a TBT, that is threaded binary tree, then what can be the issue related to it. As I have told you, the issue which arises in threaded binary tree is, or the problem which arises in threaded binary tree is something like we don't understand that which address is stored in the pointers. So whenever we are converting anything into a threaded binary tree, these pointers are storing some addresses. Now while converting your binary tree into TBT, we know that the right pointer of I is pointing to the ancestor or the parent of it, but actually when we are programming it, or when we are doing programming, your program doesn't know that what is the address of right pointer of I, whether it is an address of a child or whether it is an address of the ancestor or the parent of it. And that's the main problem which arises. So what is the solution for it? Now we have a solution in threaded binary tree for the same. So what it is, before that, let's have an overlook of it. Now as I told you, the problem which arises in TBT will be something like, I don't know whether the address is stored by a pointer is a child address or the parent address or ancestor address. Then whether your pointer contains an address of a child or parent or ancestor, then what we have a solution. So what we have done, instead of dividing our node into 3 parts, we are dividing it into 5 different parts. Now let me explain you the structure of your node. Now for the solution of us, we have converted our node from a 3 unit node to a 5 unit. Now which are those 5 units? 5 different units or 5 different parts, those are available. Those parts are nothing but character data, the first thing. Second is integer left flag, integer right flag, structure node star left and structure node star right, which already were there. The 2 new things those we have included into it are the left flag of yours and right flag of yours. Now I'll tell you what left flag and right flag is. Let me explain you first. Now when I'm talking about the structure, the 5 item structure of my node, then the leftmost and rightmost pointers are nothing but the left pointer of your node and right pointer of your node, correct, which were already there. So these 2 pointers are pointing either to the left child or either to the right child of yours. Then the 2 new things those we have included are present as the left flag of mine and right flag of mine. Now what is the use of this left flag and right flag? Now left flag and right flag will tell you whether the address is stored by your pointer, that is left flag pointer or right flag pointer, is an address of a child or is an address of a parent or ancestor. Then how it will be decided whether the address is related to child or ancestor? If flag is equal to 1, means if your left flag is equal to 1, it means that what? It is pointing to a child. So always remember, when you have child, your left flag will always be 1. Else means if your left flag is equal to 0, it means that your left flag is pointing, or the left pointer is pointing to whom? It is pointing to the parent or ancestor address. The same is related to right flag also. If right flag is equal to 1, it means that my right pointer is pointing to a child. If right flag is equal to 0, it means that my right pointer is pointing to whom? It is pointing to either the parent or the ancestor of mine. So this is a simple solution which is included, because of which instead of 3 things, now we have 5 different parts present in my node, correct. So let me write down all the nodes those were there in my TBT. This is A, this is B, this is C, then D, this is E, this is F, this is G, this is H, this is I, and this one is j. Final one is j. Now let's see that how they are pointing to each other. Now let's start with node A. Now as node A is already having what, left and right child, so definitely my left flag and right flag are having value equal to 1. Why? Because if you have a child, if your left and right flag both are pointing to the child nodes, then the flag value has to be 1. That's why I have given flag value is equal to 1. It means that left and right are already having some childs. Now come to B. B is also having what? It is also having 2 child. That's why the left flag of B and right flag of B is equal to 1. Same is with C. Left flag and right flag of C is equal to 1. Then D has 2 childs. D has 2 childs, H and I. That's why the left flag and right flag of D are equal to 1. Then E has no child. We'll talk about it later. Next is what? F doesn't have a child. G has only one child, correct? It means that the right flag of G has to be equal to 1. Now what we have discussed? We have discussed that if flag is equal to 0, right? What does it mean? It means that if your nodes doesn't contain any children, if they are not pointing to any children, what does it mean? It means that their left and right flag is equal to 0. It has to be equal to 0, and that's the only reason why H, the left flag of H has to be 0, right flag has to be 0. The left flag of I is 0, right flag is 0. Left flag of E is 0, right flag of E is 0. Left flag of F is 0, right flag of F is 0. Then right flag of G is 1 as it is having one child, but left is not pointing to anything, so left flag is equal to what? 0. So this is how what we are doing. We are providing values to pointers, correct? Next thing we will see in next video. Thank you. Hello everyone. Now let's continue with the remaining one. Now in previous lecture we have given values 1 and 0s to all the nodes. We are remained with J. Now J doesn't contain any child, so that's why the left flag of J is 0 and right flag of J is 0, correct? Now what is remaining? The remaining parts are nothing but the left and right pointers of mine. So we have already know that when we are talking about left and right pointers, left and right pointers, either they are pointing to the child or they are pointing to whom? To either the parent or to the ancestor. Now it depends on what? Definitely it depends on my in order traversal. Now what is left child? Now left pointer will point to whom? To the in order predecessor of the given node. Now in this case, what will happen? H doesn't contain what? It doesn't contain any predecessor. So what does it mean? It means that I have to keep this value as null. I have to keep this value as null. What does it mean? It means that if left flag is equal to 0, what is the meaning of left flag is equal to 0? Left flag is equal to 0 means the left pointer is pointing to either parent or ancestor. And if I am keeping my left pointer is equal to null, what does it mean? It means that it doesn't contain any ancestor or parent, which is not true. So I cannot keep it null. Is it right? The same thing is applicable for the rightmost pointer of yours. The rightmost pointer of yours, J, correct? The rightmost pointer of J, I cannot keep it null. If I am keeping it null, what will happen? The meaning will be something like the right flag is equal to 0. If right flag is equal to 0, it means that it is pointing to either parent or ancestor. But if I am saying the pointer is equal to null, it means that it doesn't contain any parent or ancestor, which is not true. It does have parents and ancestor, as well as your left node, that is leftmost node, also has ancestors and parents, definitely. So I cannot keep them null. So there is a special thing available in this case, is nothing but what? Called as a dummy node. If you can see over here, this is called as a dummy node. I have created a dummy node, and these two leftmost and rightmost pointers of mine, they are going to point something what a dummy node is. Now before going for the actual connection with dummy node, let's try and give values to all these remaining pointers. Now what will happen when I'm saying that the right pointer of h, as it is 0, 0 means it has to point to whom? It has to point to the parent of mine. So it will go and point to whom? D. Why? Because the right pointers will always point to the in order successor of it. What is in order successor of h? In order successor of h is D. Now the left pointer of I, left pointer will always point to the in order predecessor. Now D is the in order predecessor of it, so it will point here. Right pointer will point to in order successor, which is B, so it will point over here. Next is what? E. Left will point to whom? Left will point to B. Why B? Because it is in order predecessor. Right will point to in order successor, which is A, so it will point to A, right? Then left pointer of F, left pointer of F will point to A again, in order predecessor. In order successor is whom? C, so it will point to C. Then G, left pointer will point to whom? It will point to in order successor, so it will point to C. And the left pointer of J will point to whom? To the predecessor, the in order predecessor, that is G, so it will point to G. Correct? What is remaining? As we have discussed, remaining parts are nothing but the leftmost pointer, that is left pointer of H and right pointer of J. Now left pointer of H and right pointer of J are going to point a dummy node, which I have already created in my threaded binary tree. So they'll point to this dummy node of mine. The left pointer of H and the right pointer of J are pointing to the dummy node. Okay, now they have pointed to the dummy node of mine. My dummy node doesn't contain any value. My dummy node doesn't contain any value, and it doesn't have any what? Child. Is it right? It doesn't have any child, correct? Then it doesn't contain any ancestor, right? It doesn't contain any ancestor. That's why the left and right flag of my dummy node should be equal to 1. The left and right flag of my dummy node should be equal to 1. If left and right flag is equal to 1, it means that it has to point to the child of its. Then who are the child of my dummy node? Now the left child of my dummy node is nothing but the root of my threaded binary tree. Do you understand it? The left pointer is going to point the child as root of my threaded binary tree, and the right pointer of my dummy node is going to point himself. Right? If he is pointing himself, it means that what? It doesn't have any ancestor, but it does have a child. It is either pointing to himself or it is pointing to the rest of the children, those are present into it. Now why we have created that dummy node? Now this dummy node is created just to keep the consistency of all the pointers, and this is the solution which is available for what? To find out whether the addresses stored by your pointers are the addresses of child or parents. I hope you have understood it. If you have any doubts, please ask me personally on WhatsApp, or you can put a comment on our Google Classroom also. Thank you everyone.